Alright, so here we go with our review for assessment number 10. So your first job in basically lots of things in this chapter is when you see any factoring to be done, you need to do it. So x squared minus 4, that's the difference of perfect squares, so that's x plus 2 and x minus 2. And you can draw the puzzle for this one, but you could also start to now grow and figure that out just by looking at it. You know, you need x's here. What multiplies to 10 and makes 3, so you'd need 5 and 2, positive 5 and minus 2. So you have to look across here and figure out your common denominator. So my common denominator would be, they both have x minus 2, so I'm definitely going to keep that. This one wants x plus 2, and this guy wants x plus 5. So by the time I'm done, I have an addition problem to do up here. 3x needs to receive x plus 5 because the bottom got x plus 5. All right, how did I grow x plus 5 and x minus 2 to become this expression? Well, I gave it an x plus 2, so I need to give x plus 2 to the 3. All right, so now we just need to work that out. So I'm just going to do this over to the side. This becomes 3x squared plus 15x. And this becomes plus 3x plus 6. Because what I need from that is I need an expression. 3x squared with, combine like terms, plus 18x plus 6. All over. And the bottom, the denominator, just stays factored. Like that. And sometimes you can check and see if the numerator factors. But, if we do that, I pull out a 3 because I notice they all divide by 3. X squared plus, that would be 6x plus 2. Nothing multiplies to 2. That also makes 6. So I'm done. But, frankly, that's just like every once in a while that happens, but we don't have to really worry about it. We're not going to do that to you here. All right, so over here, again, common denominator. So this one's actually a little bit easier than the first one. My common denominator is just these two items, x minus 5 and x plus 2. So I need to give a minus up there. I need to give the 4 the x plus 2 because it didn't have it before. I need to give the 2x the x minus 5. All right, so I'm just going to work that out here. I get 4x plus 8. Now be careful, minus 2x squared. And minus 2x times minus 5 is plus 10x. So when I combine like terms, negative 2x squared is alone. 4x plus 10x is 14x, and plus 8. And that goes over my denominator. Okay, all right. So in questions 3 and 4, so in question number 3, I have to, again, factor everything that I can, but this is a division problem. So I no longer need a common denominator. I'm just going to factor things, and I am going to flip the back fraction because this division turns into multiplication by the reciprocal. So this guy, what multiplies to 5 and make 4? So you can make your puzzle if you want, but we need 5 and 1. So if I do minus 5 and plus 1. So these easy ones you can start to not have to write the puzzle down because there's nothing in front to make this difficult. This guy right here, it's a different kind of factoring. I have to pull out GCF, so pull out a 3. Leaves you x plus 2. This is perfect squares, so x plus 1 and x minus 1. All right, so as I write this one down, the front's going to stay the same. But the second fraction is going to reverse, or is going to do the reciprocal. 3 and x plus 2 down here, and then x plus 1 and x minus 1. All right, now the good part, start canceling. X plus 1's go, x plus 2's go, and that's it. So x minus 1 is in the numerator, the 3 and the x minus 5 are down below. And you can multiply that out down here if you want to, but it's fine, just leave it alone. All right, on number 4, we have what's called a complex fraction. We have fractions inside of a fraction, all right? So it's going to kind of follow the same process. This is division. You have one fraction divided by another fraction. So the first fraction stays the same. The second one flips over, all right? So this first fraction stays the same. R minus 6 over 24 R squared. Shoot, that's a 7. Whatever. Okay. All right, I'm going to write that again. All right, the second fraction flips and multiplies, so it flips up. I got 8r to the second over 6 minus r. Well, these I noticed they're the same, but they're backwards. They're the reverse, the opposite of each other. So I can cancel those out, but then that just makes me put a -1, or just a negative sign. 8 and 24 reduced to 1 and 3. So r squared and r seventh, these two are going to go away altogether, and I'm going to have 5 left, because remember I subtract those. So this goes away altogether, and I'm going to cross that out and put a 5. All right, so all I have up top, it looks like, is my -1 times 1. So I have to put a 1 there. On the bottom, 3r to the 5th. Okay. All right, and for number 5. So number 5 is similar to number 4, except it is multiplication. So there is no flipping, I guess you'd call it, no reciprocal. So I just have to factor it up. They have a 3x in common, which leaves me x minus 3. So I think I'll start writing it down here, 3x and x minus 3. These have a 3 in common, that's all I can do, and it leaves me x minus 4, times this 4 minus x stays. Now this one, I'm going to put a 2 up here because it leaves me x squared minus 9. So then that's perfect squares. So that 2 stays, and then that breaks into x plus 3 and x minus 3. Okay, x minus 3's directly cancel. These 3's directly cancel. And the only thing left is this and this. Well, they're opposite of each other. So when I cancel them, I'll put a negative sign, -1. All right, so my numerator is -x. My denominator is 2 and x plus 3. All right, over here, I have to clean this up to get the radical alone, so add 4 to both sides. So I have 3x minus 5 still in the radical equals 5, and that's a possibility, because if this was a -5, though, I'd have to say no solution. But I can do this, so I'll square both sides. So 3x minus 5 pops out, because these cancel each other, because remember a square root is a 1/2 power, and 1/2 times 2 is 1, so it cancels. Right, and then the back part, 25, add 5, and my answer is 10. Okay. All right, on number 7. So on number 7, it's an equation I'm trying to solve, so I need to go ahead and mention which values are not allowed to be answers. So whatever makes the denominator 0, I can't have that. So x cannot be 1. X can also not be -3. And then let's factor this. I bet it's just a combination of these. So let's see. What multiplies a 3 and makes 2? Well, 3 minus 1. So that's exactly what these are. And so oftentimes it happens. All right, so let's go across and create common denominators. So I will have to, my common denominator is going to be this x plus 3 and x minus 1. So to make these denominators match that, I have to give an x plus 3 over here, right? So I need to give this one an x plus 3. I'd have to give this one an x minus 1. So I have to give this one an x minus 1. So I end up, and 32 gets nothing because it already has everything. So I end up with an equation to solve. So once I have the denominators to matching, I don't need that anymore. I was just trying to see what would I have to do to keep the weights the same. So I have 2 times x plus 3 plus 4 times x minus 1. And you could work these out as you write them down, equals 32. So I get 2x plus 6 plus 4x minus 4. Clean this up, I got 6x plus 2. All right, so take away 2. And so I get an answer of 5. And I just have to do one check and make sure that that wasn't one of these. So it's good. All right, over on number 8, I cannot use -3 if it were to be the answer. I also cannot use -8. All right, so my common denominator is going to be both of these things together. So over here, I'm going to give it an x plus 3. And over here, I'm going to give it an x plus 8. It's kind of like cross multiplying as well. So I have an x times an x plus 8 equal to a 4 times an x plus 3. All right, so I get x squared plus 8x equals 4x plus 12. So now I notice that I am going to have to factor. So I need everything brought to the left side because that's positive here and I want to stay that way. So take away 4x. So I got x squared plus 4x, because 8 minus 4. And this 12, there's nothing to go with, so we just bring it over here. Positive turns into negative 12. All right, let's factor. Let's see, what multiplies to 12 and makes 4? So that would be 6 and 2. So I'd have to have x plus 6 and x minus 2 to make that happen. You could also draw your puzzle. All right, so my answers are negative 6, what makes that 0, and positive 2. So you do a check, and those aren't these numbers, so they're perfectly fine. All right, number 9, we got some exponent rules to do. All right, so when I multiply, I add my exponents, and I multiply my numbers. So I got 12x and then y to the 6th. In the denominator, I multiply my exponents here, but 2 squared is 4. 2 times 2 is 4, and 1 times 2 is 2. So now I divide and I subtract my exponents. So 12 divided by 4 is 3. I have an x here and 4 of them down there, so that means that's going to go away, and this is going to be 3 left over. And I have 6 minus 2 is 4, so these are gone, and there's 4 left up here. And that's it. All right, over here, I'm going to be looking at the degree and also the leading sign, positive or negative. So when something is even, remember even exponents, even degrees, they either both go up, both ends go up, or both ends go down. Since it's negative, they both go down. So I need the last parts to be negative, negative. So that's letter B. Even again, so that's the situation, both going up. So left is up, right is up. So that's part A. All right, odd. So when you have an odd degree, usually the right side goes up and the left side goes down if it's a positive leading coefficient. But, so that one is left side down here, or right side up, so that's letter D. If it has a negative sign, these things get switched. So that means that the right side goes down, left side goes up. So that would be left side up, right side down. All right, let's see, number 11, we have a square root function graphed over there. Remember, you do have your calculator to help you out on these if you want to check and see as well. So, increasing. So this graph right here is starting and it's coming down. It has a negative slope. It keeps going. So it does not increase at all. There is no interval of increase because it is decreasing the whole time from 2 on to the right. So from 2 to infinity, it's decreasing. We don't say bracket because at 2 it's not doing anything yet until it starts moving that way. The domain, well, it starts at 2 and goes off to the right. So it starts at 2, goes to the right, parentheses, it actually touches 2. The range, it starts at 1 and it's going down. So that's negative infinity and a 1. So I have to put the smaller thing first and then a 1, bracket, parentheses. All right, describe the transformations from the regular square root function. So the regular square root function kind of looks like this. So what happened to this graph? Well, it moved right, up, and it got reflected over the x-axis. So right, 2, up, 1, and a reflection over the x-axis. All right? Okay, so let's make that happen. So a reflection has a negative sign in front. Right 2 would mean minus 2, and afterwards, plus 1. So what I was talking about, you could use your calculator. So you can check that. All right? So type that in. Go to y equals and type in negative square root of x minus 2. Jump out, put plus 1, and graph that. And you see it's the picture that is like on the page. Looks a little bit uglier, but same thing. All right, so this cubic polynomial. So cubic means x to the third, right? So increasing. So increasing is when something has a positive slope, decreasing is negative slope. So this part is definitely increasing, then it goes decreasing, then increasing. It changes here and here. This point is 1, 0. This point over here is, what, 3, negative 4. So for increasing and decreasing, we use our x values, right? So my x value of this section right here is coming from the left and stopping at 1. So from negative infinity to 1, no brackets. And that's also increasing here. So that's starting at 3, this x value, and off to the right. So that's from 3 to infinity. This one was from negative infinity to 1. So 3 to infinity. Well, the section in between right here, that was from 1 to 3, well, that was my decreasing section. All right, my domain. This graph extends outward forever. It keeps going right and left, so negative infinity to infinity. Or by the time you're done here, you can put your symbols, your infinities right and up. This one's left and down. Right, you can put those if that helps you. The range, it goes up and down forever with no breaks in between. So negative infinity to infinity, all real numbers. All right, the end behavior. So what's going on? Left side is going down, like we said. Right side is going up. And so if you have these labeled, your answers are right there. X-intercepts. So 1, 0. Now notice that's going to turn into a factor, but it's a double root. So when I turn it into a factor, x minus 1, I'll put a square on it because the bounce. The other x-intercept is 4. So that'll turn into a factor of x minus 4. Remember, your intercepts and your factors have opposite signs because these are the zeros, and what makes this expression 0 is 4 minus 4. All right, y-intercept is right here. It's 0, negative 4. All right, that is it. I'll see you next time. Bye-bye.